7.65. So some of them I have to wake by just pushing the make sure connect one of the live batteries, the one that had the battery the power, and touching positive to positive, negative to negative. The voltage transfer wakes the other guys up. So this is how you wake up the BMS or activate the BMS on the batteries that you think probably they're dead or they're not workable. They're all good. It's just the BMS shut down at a certain threshold, battery threshold, and makes the batteries not to drain all the way and ruin the battery. So this is what it is, and I just want to show you. We're going to be interconnecting these guys. If the negative is going to be the end part here, so we're going to connect series and go to these series. The two red wires are connected together. It doesn't matter. This is a 14 gauge, the bigger one. I think these are 18. So join these together, connect them together, and go into your series configuration and all the way here. So I configure them this way, so it will just make it exactly. So I soldered it, and this one's gonna be the end lead, since we have an end right here. So this is what we have to do. All the negatives gonna be on this side, and all the positive on this side. Excuse me. Then I can use bus bar, bus bar, to be here and connect them to the terminals. Connect them to the bus bars, and after that I have the solid bus bar will have the main positive, while here has the negative. And we get all these guys connected. 55 amp hours at 24 volt. I wish I can still get these batteries, because I was gonna build something of this, maybe all in parallel. This is one battery, like it's just 7.5, and keep on going, so I can build up more amps here. If it's a 12 volt, it would have been really nice, because two batteries is a 10, the other batteries is a 10, so parallel them you get 20. So you keep on, but because of the wires, you don't want to just try to build up a lot of amperage into this. Not too big, so 14 gauge, it can carry some good amount of power. You know, I think they can handle up to what? Around 15 amps or something like that. Yeah, because 10 gauge can handle 30, 12 gauge 20. Yeah, about 15 amps this one can handle. And the BMS is a 10 amp BMS built into this, I suppose. So the wire is going to be okay. So you don't want to stress the wires with a lot of current, so we can go into high voltage. So 24 volts will be a good thing. And I can able to link it with this other one here. Connectors here. It's called butt splice waterproof, that can take a 10 to 12 gauge. And remember guys, these wires are 14 gauge and these ones are 18, the little ones. So I decided you have to put them together. So even that, this connector is still at a higher scale. It runs about 12 to 10 gauge wire. So I'm still on the good side. I was gonna solder it, but a lot of people don't like soldering. But this, I can able to use this and heat it up, and becomes a heat shrink, and all is gonna melt and hold itself really good here. And all the negatives gonna be here. Now I have to go to the buses and take all these guys all the way. So I have 5 strings of 5s, 5 strings of 4s. Batteries. So these are all going to be the ground, the neutral or negative. So this side here is going to be all the positives. So the positive are going to end up having a beefy wire, because you have a 14 gauge plus another 18 gauge. So the positives are heavy duty. So yeah, I just decided to show you guys, and can be working with one hand, both hands, and try to film at the same time. But this is the progress. I'm using these guys. If I decide to change in the near future, I don't know if you can read that. I get it from Menards, and this one can go up to 600 volts max to 1000 volts. You can see, and that's the proof right there. I was gonna use the other one like a spade connector, but I don't want to cut them. I can just fold these guys and lay them down just like I did on the other batteries. And anytime I want to interconnect or I want to interchange the connection, then I can just cut this splice out, remove the wire. That's why I don't trim the wire, I don't cut them short. Some people probably get them all short to be really nice and neat, so I can just go like this and set them the way I want them. And I'm going to be testing all the voltages here soon. Like and subscribe from the command center of the JW Solar USA in Minnesota. Thanks for watching. Love you guys all. By charging, we're not going to put any charger into this at all. So what we do, we utilize the power that we already have. So we're not going to waste anything. So we decided to jump these guys here, and I paralleled it right here and tied it right here with a tie wire. You get bonded together, and now the voltage started going up. So all the voltage is going to be running the same. So let's check it out and see how everything is working for us right here at JW Solar USA. I'm just going to tap on one of the corners right here and see on the other side right there. It's going to read about 30 point something now. There you go. So it's 30.35. So I just touch it, so it's not like proper contact. So let's push it a little bit. Let you see. So it's 30 point something volt. So it's boosting the low cells. The low cells are having now the power transfer from the other cells while being utilized instead of putting a charger. So this is how I'm going to balance them for now. And when I'm ready, I just put a charge controller. So in the other way around, guys, I happen to have the Midnight Kid. Well, this is the Midnight Kid, no BLK. This is the WH, see the white. So this one I got a deal, and I bought it. And I'm gonna utilize this, the one that's for the marine, like for the boats or something. So it has external bus, but it's not like the other ones. It's supposed to have something here, and that case doesn't come, but you can use the thing. So I decided to label it. Here's the battery, and here is gonna be the solar, and you can see it right there, solar. I labeled that, and this middle one is gonna be the load, which I might incorporate this guy to this. Then I have the other battery, which is the Panasonic, the CGR batteries, and it's on the other side, which I have to utilize, and they have the same parameter. If you've been watching this when I was talking, see it's fluctuating. Now the 7 is changing to 7 because the transfer of power is happening here. It's taking the borrowing from the higher cells on that BMS and transfer it. So if you watch most of my BMS batteries that are BMS, I don't put the BMS for myself. It's already built in this, because the BMS that comes with this thing is they're very reliable and they designed for it, and they, it's not just gonna fail like any other BMSs. So I trust them better because they are rated. Most of the other BMS are Chinese. I understand. I have some BMS I haven't done anything. I have balancers. I haven't done anything yet because I don't want to do something when I'm not home. I want to go somewhere. I don't have to think or worry about my system at all. Make sure that it's safe. But I always use my batteries without BMS. If you look at over there, you can see a project down there, which is the Volkswagen e-Golf. Batteries is running the house, you know, fantastically. I can't even complain. I love those batteries. I wish I can buy a lot of them, or I can buy one old car or 2 cars or maybe 10 cars. I'll build the biggest battery bank ever. So look at that. We gain millivolt. It was fluctuating 30.35, we go 30.36, now 3.7. So it's going to, I'm probably going to let this one balance out, and after it settles at a certain number that doesn't fluctuate anymore, that time I'm going to charge it. So now I just want to use the opportunity. If I put a charge right now, I know they're all going to power it up and charge it, but the other ones already have a high voltage on them. So let them just share the power, and I can give them a boost. So I can able to charge this battery all the way to 33 volt, supposed to be 33.6. So I can able to leave at 32 or 33. The voltage is already there. Maybe just need some amps to fill up this bank. So this is what it is, guys. I just want to share with you, and thanks for watching. JW Solar USA. Sorry, I have to explain this to you guys, and so more talking. But if I don't talk, how are you gonna understand this? Some people say, well, the video is too short. Some people say the video is too long. Some people say just get to the point. But you can get to the point on certain people already know what they're doing. Some people don't just call and say, well, I don't understand. You should have started. I'm just new into this. So that's why most of the time I explain things for the general good of everybody. And if you think you know this part, you can fast forward or maybe let it play. Maybe I can say something that you never heard before, or maybe you're going to throw a comment or idea or something there. That's how we learn. It's patient. If you're not patient enough, you're not going to be able to learn. It's not like what you want now, that's what you get. You have to be patient and listen to other people. That's how we learn, and that's how we do things. And if you want to learn, you want to be the smartest guy. You collect a lot of information, different ideas, different strategies. Everybody has a different way of doing things, and all our systems are all different, totally different from each other. So I might probably say something like this. You go to the other guy, he's saying that, but use your discretion. Take my idea or take somebody else's ideas, or drop my idea and go with somebody else. Or maybe you can do a comparison on both of them and utilize both ideas, and you build a fantastic system, which fill up a lot of ideas into them. And that's how you build awesome systems. Don't just get stuck on one and say, well, this is what I have to do, and this is the other video. This guy has more subscribers, got more viewers, or whatever. Yes, our systems are all different, and we do things differently. We are humans. We do things differently. We behave differently. We interact differently. We socialize differently. And even jobs or whatever, job qualities and equipments are all different. But if it comes to powering our house, we know that we're going to use solar. Is the same thing. As long as you have electricity, that's all matters. Some people say, well, I can't afford your machines, and oh, your machine is crap. I don't care. Somebody has a crap machine. As long as he knows how to produce electricity for himself, becomes sustainable, and is independent, or she's independent, and that's all matters to me. Look at that. We just gained another millivolts as I was talking, because I want you guys to see this when I talk about this is the traditional balancing, which I'll call manual balance. So you guys might ask me about this. I'm gonna use this guy here. You've seen it before. Professional blowtorch. I'm gonna blowtorch this one and seal all this, because I got the gap. I put the interconnect. It takes a 14 gauge, 12 to 14, 12 to 10 to 12, whatever gauge. You can work on these guys from 12 to 10. So this wire is 14 gauge, the big one. the black one, and this other is 18. So this thing can still able to maintain the current that's gonna go through that. So like I said, you see the fluctuation right there? It's charging. Well, before I'm gonna let you go, I was gonna make another series video because of this. Then I think I can able to do this. Get this guy and turn the gas on, and we're gonna fire up this guy. Push this button right here. There you go. See that? Then I can release this. Then I can able to go here. Now the heat shrink is completed, you can see everything sealed up pretty good. See somewhat, so it can back smoke, whatever. So it's already hold up pretty good. So these connections are not going anywhere anymore. So you can see everything is nice and good. So let's try and put back the probes right here and set it right there, and turn the meter to DC. So it's reading 30.39. It's almost at 34. We started at 30.35, something like that. So the voltage is transferring, and that means our connections are still good. And thanks for watching. This is how we complete this video. Stay tuned while we're gonna put them together. Bye for now.